This is the fifth chapter of Introduction to Oracle 999 SQL. My name is Tayo Akikomi. In the previous chapter, we talked about single row functions, and we mentioned that single row functions always return a record or a result for every row in that table. We'll move our discussion a little bit forward by talking about group functions. Group function, unlike the single row functions, will go over several rows before it can return a result. In this chapter, you'll learn how to use you'll learn about the available group functions. You'll be able to describe the use of group functions. We'll be showing you how to use the group by clause as part of a select statement, and you'll be able to include or exclude a group of records from the record set by using the having clause. Group functions operate primarily on sets of rows to give one result per group. In other words, unlike the single row functions, unlike the single row function that returns a record, a value for every record, the group function will require a set of rows before it returns a result. An example of this is if we're trying to find the maximum salary in the employees table, that will return only one record. In other words, the maximum is going to be 24,000 in this case. The max function is a group function because it does not return a value for every row. There are some other types of group functions. There is the average group. There's a function called average, AVG. There's the count, which gives us the count of the records in a table, in that particular table. The max gives us the maximum value of a numeric value in a column. The mean gives us the minimum column value in a numeric column. A standard deviation gives us the standard deviation. The sum sums up the values in the column, and the variance tells us the variance of the record of the values in a particular column. Here's how to use a group function. You do your select. You can put in your column name, which is optional. By the way, everything inside the square bracket is optional. But the group function, you can specify the group function, for instance, sum, and specify the columns you want to act on from a table. The where condition is optional. The group by condition, the group by column is, the group by clause is optional, and the order by column is, order by clause is conditional. Let's start with the average and the sum functions. You can obviously use the average and the sum function for numeric data. In other words, they apply to columns which are defined as number data type. And how to use it is to go ahead and use select average salary, for instance, max salary, mean salary, and sum salary from employees. Your where clause can be used the same way that the same thing goes for your join conditions. But what goes in here though is that the average salary will be calculated for the whole table. The max salary is calculated for the entire rows in the table, and so does the sum and the mean, which is the minimum. You can also use minimum and max, or minimum maximum function in your select statement. The difference only is that the minimum and the max function can be used on any kind of data type, which includes, believe it or not, characters, data, the dates, character, dates, numbers, and all kind of data types. And remember, we talked about dates, and we said the date is the date is considered. Today's date, for instance, is considered to be higher than yesterday. So you can get the minimum and maximum hire date, for instance, in the employees table. The count function returns the number of rows in a table. So this, for instance, you can say select counts star, which means counts everything in the table from employees where department ID is 50. This way you get number of records in that table that has the department ID equal 50. It is important to put in at the back of your mind all the time that the group functions always ignore the null value or the records with the null value. So if you use an count function, for instance, it returns the number of rows with non-null values. In other words, even though there are 20 rows in a table and maybe 2 of them does not have a value for that particular column that you're going by, then the count is just going to ignore 2 of them and return 18, even though there are 18, even though there are 20 rows in that table. For instance, look at this example where we're doing a count for commission percent from employee where department ID equals 80. It returns 3. Now that might give you a false impression that there are only 3 records in that table under department ID 80, but that is not true. The only thing though is that there are only 3 people in that department that have commission percentage. So you just should keep it in mind. Now you can always use the NVL function to overcome this, but we're going to see that in a little bit. Now the distinct keyword is a keyword that you use to enforce that only distinct rows are returned. So in the same way, if you use a distinct along with a group function, then you're making sure that it's only going to count, for instance, in the case of counts, it's only going to count distinct records and not repeated values. So in this count, for instance, we're trying to count the distinct department ID. This is a way to make sure that we don't count department ID 50 4 times because it shows up 4 times in the table. Generally speaking, the group functions ignore null values, just like I've showed you with count. But the way to get over that is to use the NVL function. The NVL function, remember, is one of our single row functions that will give us an alternate value in case it comes across a null value in a particular column of interest. So in this case, we're using the NVL value to make sure that if someone does not have a commission percentage, that NVL value will make sure to return 0. Then you can find the average. Then you're sure that the average is calculated across the whole table instead of being calculated across the non-null values in the table. All the while we've been talking about group functions, and all the group functions we talked about actually acted over and returned a single value for all the records in the table. There are times that we need to break our statistics down, for instance, by department ID or some other grouping criteria. So so in essence, we're trying to, for instance, find the sum or the maximum salary based on the group. In this particular case on the slide, what we're trying to do is to find the average salary for every department. Now, if you look at the table on the left-hand side, you find out that in department 10 we only have 1 record, but department 20 has 2, and department 50 has, I believe that is 5. If we want to find the average for each department, then we want to group that department. We want to group the records by department. Then you use the group functions. In this case, the average for department ID 10 is 440. Compare that to department ID 50, which is 350. if we are able to do average by group, then it should be able to give us our value for every group. The way to group our data by department or by column is to use the group by clause. The group by clause is part of the optional clauses that comes with the group functions. Here's an example of an expression that is grouped by a column. The select statement here says select department ID and the average of salary from employee, but we should group it by department ID. This is going to give us a record set that looks like this. The record is grouped by the department ID. If we did not put this group by department ID there, then it would have given us a single average salary for all the employees in the table. You do not always have to have, unlike the previous slide, you don't need to have the group by column as part of the select list. So you can actually group a select statement by a column that does not exist, that does not show up in a select clause, as long as it is a valid column in the table. You can also group your record by more than one column from the table. For instance, in this case, what we try to do is to group, we try to find the sum of all the salary. We're trying to add the salary up by job ID, then by department. And we can do that by using the group by clause, department ID first, then job ID. So we're going to group it by department ID and job ID, and that's what we have. First, it goes by department ID. So this is department 20 right here, and these are the two groups under department 20. This is department 50, and these are the two groups under department 50. In department 60, there's only one group of people, or one group of job ID rather. There are two groups or two classifications of job ID under department 80. So this is all done by putting as many columns as you want in here, in the series that you want it. In order to write a valid select statement, when you have an individual item and a group function showing up in the select statement, that individual item has to be part of the group by clause. For instance, the department ID is showing up in the select statement. It needs to be a part of the group by clause. Otherwise, this will give you an error, and the error is that you have a non-single. It's not a single group function. You do not have a group function pointing on department ID, so it cannot evaluate that for you. So the proper way to do it is to make sure that every single or individual item that shows up here, or every single row functions that show up in the select statement must be part of the group clause. Also, you cannot use your group function in the where clause. The group function does not go into the where clause. So, which means there's another way. The group function is not the way to exclude a group of records from your record set. To do this, you need to use what is called the having clause. The having clause, again, is one of the optional clauses that comes with a group function. So you cannot, again, keep in mind that you cannot use the group function in the where clause. The way to do it, for instance, if we're trying to find the maximum salary per department when it is not greater than 10,000. Remember, what we're saying is we don't want the maximum salary to be greater than 10,000. And we just said a while ago that we cannot use the where clause to exclude maximum salary greater than 10,000. Well, you'll be doing it because this is a group function. then it will be part of the having clause. So in essence, what we're saying is you can use that you use the having clause to determine which group of record should be displayed. In other words, we will be restricting the groups based on our aggregate function or our group function. There's an example of of how to use the having clause. We're trying to select department ID and max salary, but we don't want to see the maximum salary that is greater than 10,000. So here we just use the having clause and say having max salary greater than 10,000. Anything less than 10,000 should not show up. That's what we're trying to shoot for. Here's another example that has a little bit more to it than the previous one. Here we're using a where clause to make sure that to restrict our records to only people that have the name REP as their job ID. In other words, there's some sales rep. Okay, and we're also trying to order what we get by the sum of salary. But what we're trying to show you here, I guess, is that you can still, even with the having and the group by clauses, you can still use your where clause the way you normally use it. You can also nest your group function. For instance, you can find the maximum of the average salary from your table. In summary, we've learned in this lesson how to use the group function count, max, mean, and average, how to write the queries that use the group by clause, and how to write queries that use the having clause. In practice 5, you've learned how you'll be able to demonstrate how to write queries that use the group functions. You'll be able to use group functions to achieve more than one result and exclude groups by using the having clause. This demo will show you how to use group functions in your select statement. If we consider a select statement, a really simple select statement like this, select asterisk from employees. When you execute this, this will return all the rows in that table called employees. The first group function that we're going to use is the count function. To do this, you say select count asterisk or count a particular column in the table, and if I do that, it's going to return 20, indicating that there are 20 records in that table. However, if I decide to go by column name, let's say I decide to go by select count last name from employees, I'll get 20, because if you go back to the table to look at all the records in the table, you realize that the last name column has a record for every row. Now compare that to a column like the commission percentage, where there are some records without any value, with null values in the commission percentage. What you find out is that if you do a select count by commission percentage, you will get a slightly different value. So if we go ahead and say select count of commission percentage from employees, the result is giving us a 4. Now compare that to, we do that along with count of last name from the employees table, and we get 20 for the last name, we get 4 for the commission percentage. The reason for this, obviously, is because we do in the table, the last name table has a record for, it doesn't have a null value at all, but here there are 16 null values and 4 non-null values. Our group function always go by the they always ignore the null values and they go by the non-null values. So for us to do a proper job, or to ensure that our record, our group function acts accurately, we can use the NVL function. So for instance, I'll say select count NVL commission percent 0. In other words, I'm saying if the commission percent is null, then return a 0 and do the count of that. If we go ahead and execute it, then we're saying it should do a count a 0 if there's not a value, so it can do a count properly. If we do that, then we're gonna get 20, which represents, of course, the whole total number of rows. This is something you want to keep in mind, because null values will create errors when you're dealing with counts or sum of records from a table. For instance, if we weren't doing count, if we're using doing sum or average, for instance, then it's going to introduce an error if there are null values in the table. For instance, if we want to find the average salary for employees in the employee table, then we will be doing select AVG, which is the average function, salary, which is the column salary from employees table. And if we execute this, it will give us 8,775. Now, what I was trying to point out is that if there was a null value in our table, this could not be right, because then it would have been doing our average based on by ignoring non-null values. By ignoring the null values, I'm sorry. The next function that we're going to look at is the not quite a function, but the next combination of functions that we can look at is the use of a distinct function, which is itself is actually a row function, but it can be used along with any other function, just like we could nest it with other single row functions. Let's take, for instance, that we want to determine all the managers that are responsible for the people in the employees table. In this column called manager ID, we can find out the manager ID, the different manager IDs. So if we want to find out how many managers we have, we can go ahead and do select count manager ID from employees, and it gives us 19. However, I know that this is not true, because if you go back to the table, you find out that it's actually counting 100 twice, 102 twice once, 103 twice, maybe 100 more than twice actually. The way to do it is to make sure that you only count the distinct manager ID. In other words, you want to count each manager ID once. So to do this, you have to nest the function distinct inside the count function. And if we execute this, it gives us a count of 8, meaning there are 8 different people that are managers in that table. Of course, there are some other functions that we could use. Let's introduce the max function, which, just like it sounds, will give us the maximum. So we can say we want to find the maximum salary, the average salary, the minimum salary. From the employees table. This will give us the average, maximum, minimum salary. Of course, keep in mind also that you have to be careful, make sure that there's no null value. Otherwise, one of this or all of this will be wrong. All the functions that we've seen so far they're actually being applied to the whole table, to all the records in the table, and we only get one record for all the records in the table. Now there are times this is essentially what this is saying is that, for instance, if you look at the max salary and the average salary and the minimum salary that we're looking at, this is actually the maximum salary across all 20 employees that are in the employees table. But at times we need to find out the maximum, the average, the minimum, for instance, for every department. To do this, we'll be using a new function called the group by function. So you can group this by the department ID column. And of course, for this to make sense, we want to probably put the department ID as part of our projection. So we're selecting department ID, the maximum salary, average salary, and minimum salary from employees. But we're ending up to group it by department ID. In other words, you want to see the maximum for every department ID, the average and the minimum for every department ID also. If we go ahead and execute this, then we get a record set that looks like this, that basically shows us the maximum salary, the average salary, and the minimum salary for every department ID. And you find out that each department is only shown here. And of course, this is for everyone that does not have a value in the department ID table. You can also break this down a little bit further. For instance, you know that in that department ID, there might be more than one job ID. For instance, in every department, in the sales department, for instance, there could be 2 different job IDs, job descriptions. So if you want to break it down, you want to group it by department ID, then group it again by job ID. You can go ahead and do that by just adding the job ID as a grouping column. Of course, for your record set to make sense, you probably want to put the job ID as part of the projection. So we're looking for department ID, job ID, maximum salary, average salary, minimum salary from employees, grouped by department ID. If you execute this, you find out that to start with, it does the sales rep, which happens, a particular sales rep happens to, or a particular group of sales reps do not have department ID. But apart from that, you have in department ID 20, for instance, you have the marketing manager and the marketing representative. And in department 50, you have store manager and the store clerk. So you're actually breaking down your grouping into little groups. What it's going to do is it's going to group it first by department ID, then it's going to break it down again by, it's going to break it down first by department ID, then break it down again by the job ID for each department ID. One thing I have to call your attention to, though, is that every time you have any single row or any single row function or a column that you specify here must be part of the group by function. Otherwise, you get an error. This is what I'm talking about. Let's say, for instance, I specify to see job ID here, and I decide to take job ID out from group by, or I did not put it in there. When I execute this, it's going to give me an error that says job ID is not a group by expression. The reason for this is that it's attempting to roll your statistic up by department ID, and here you are asking for the job ID. Well, what happens is that there are many job IDs. Possibly there are more than one job IDs in the department, in the same department, in every department ID. So it doesn't know how to break that down, because you're not asking for it to break it down by job ID. So there will be more than one job ID for every roll-up group. So for every department Now, for every column rather that you specify in the select clause, you have to put it in the group by function, group by clause. So that's all I need to do to make that work. However, you do not have to specify the group by columns here. You do not have to specify them in the select statement. It will still run, but only that it probably wouldn't make a lot of sense to you because you don't know what is grouped by. Well, that's about all I need to show you in the group by function. If you have any questions, go ahead and get in touch with your instructor.